In our previous chapter, we were talking about functions. We defined functions, looked at linear functions and different properties of functions and their graphs. In chapter 2, we're going to focus on equations and inequalities. Okay? And even if you're just trying to study functions, you run into equations and inequalities. If you want to find x-intercepts, you have to solve an equation. Okay? So equations and inequalities is our next topic. In the first section, we're going to talk about the simplest type of equations, arguably the simplest type, which are linear equations. So taking linear functions and looking at linear equations where we're trying to solve for x or whatever the variable is. So linear equations and problem solving. So first of all, what is a linear equation? Well, it's one where your variable, think about it, your variable just appears with the power of 1. Okay? It can have a coefficient, you can have other constants. You won't have x squared, that's called quadratic. You won't have x to other powers. If x is your variable, it'll just be x to 1. No fractions with x on the bottom. No square roots of x, those are fractional powers. No absolute values. Now, there's lots of other types of equations we can run into, and we will in this chapter. But linear equations are ones that, if you simplify them, can be written as your linear function equals 0, ax plus b equals 0, or mx plus b equals 0 if you wanted to use an m there. But some of them don't look like that. They look a lot more complicated and you have to simplify them first. But a linear equation could be written in the form ax plus b equals 0, where the a is not 0 because it wouldn't be linear if it didn't have the x term. Okay, so examples, 4x plus 2 equals 0. That's exactly in the form ax plus b equals 0. But 4x equals 4, that's a linear equation. If I subtracted 4 from both sides, it would be in the form ax plus b equals 0, where the a would be 4 and the b would be negative 4. 2x equals 3x minus 1. Again, when you look at the variable, it's just x, not x to any power other than 1. No fractions with x on the bottom, no square root of x, things like that. Now, the coefficients can be anything, not just whole numbers, but anyway, that one is a linear equation because I could subtract 3x and add 1 to both sides and put it in the form ax plus b equals 0. So that's what we're talking about with a linear equation. And you probably have a good idea of how to solve linear equations. We've already had to do it in previous sections when we did things like find x-intercepts. You have to get x by itself on one side, right? You have to find all of the x values if x is your variable. You can use other letters, but if x is your variable, and which is the most common, just by convention, people have decided we're going to use x for the inputs, y for the outputs more often than not. But anyway, solving an equation means to find all the values that when you plug them in, you get true statements. Okay? And this slide I'm just pointing out, we have lots of different words you might see that kind of mean the same things. When we talk about solving an equation, we look for the solutions. Sometimes we call those roots, and sometimes we call them zeros if our equation is set equal to 0 on one side. So those, in a way, are synonyms for each other, or they're often used in similar ways. Equations can have any number of solutions. We're used to getting things in our examples so far like x equals 2 and getting one answer, but that's not always the case. You may get no answers. You may get 10 answers. You may get infinitely many answers. Depends on the equation. So we talk about the solution set, which is the set of all solutions. And whether we think about this explicitly or not, what we do is we go through a series of equivalent equations when we're trying to solve an equation. An equivalent equation is one that has the same solution set. So what we do is, I have in orange in parentheses in the middle of the slide, we get x by itself on one side, right? That's the very informal way of saying it. But what we really do is we take our equation and we keep transforming it algebraically using properties that keep it equivalent to find an equivalent equation where we can just read the answer and get like x equals d, where d is some real number. For example, if I have x minus 2 equals 4, I could add 2 to both sides, keep everything balanced, keep it equivalent, and get x equals 6, and then I can read that my solution set is 6, the number 6. Okay? So the properties, whatever we do to one side, we do to both. We keep it balanced, and that'll give us equivalent equations. So if a is equal to b is some true equation, some true statement, and it says here real numbers, but even algebraic statements, like 2x plus 5 equals 7x minus 3 or something. If you have an equation, you can add the same number to both sides and keep everything equivalent. You can subtract the same number from both sides. You can multiply the same thing on both sides. And you can divide the same thing on both sides. However, if you divide by 0, it's undefined and wouldn't help us at all. So we can add, subtract, multiply, and divide the same quantity to both sides, and we don't want to divide by 0. So what we do, get x by itself on both sides. If you have a more complicated equation, you might have to do some simplification first. Use the distributive property if they're parentheses. Multiply things out. Combine like terms. And then to get x by itself on one side, we would start with addition or subtraction to move all the quantities with x to one side and all the ones that are just numerical to the other side. And then in the end, if you wind up with 2x or 1/2 x or something like that, you might have to multiply or divide to get x completely by itself.